Okay, we're going to do the second Universe and More activity. Now, the first time we went through it, we had some trouble with it. First thing being that this URL is incorrect. You have to delete this to.blogspot.com. So instead, we'll just come over here and go to universeandmore.com. And that's all you need to get there. Once this is up, we'll go to Games and Graphing Challenge again, like we did before. Click again. Again, you can turn the sound off and hit play. Now, with this new one, we're looking at going to World 3. So this is World 1, so we'll go World 2, World 3. As you can see, there's much less to do here. So begin on level 1. So level 3-1 is going to ask you several different things. It's going to ask you for the initial velocity, the final velocity, what direction it happens to be going, and quite honestly, I think this is incorrect. I think we should have negatives on this side and positives on this side, but, it is what it is. Is that object speeding up or slowing down? Is there an acceleration? And is there a slope of the line and what it is, positive, negative, or zero? So if we start on World 1-1, again, we get the same ideas here, except what has changed is that this is no longer a position time graph, it is a velocity time graph. So how do you get here? Well, you'll probably think that we should change the initial position to 4, because that's what we did last time, right? So if we do that, you can see that that's not going to work this time, because this is not a position time graph. Instead, it's velocity time. So we're talking about staying in motion. So again, like we said before, don't change too many things at one time. The catch here is that the object, in this case the orange slice, has to remain on the screen. So that's going to be a problem. Let's say we figure out now that it needs to be at 4 meters per second. So we're going to change our initial velocity to 4 meters per second. And as you can see, the arrow points up and it indicates that that's where we're at. So if we begin, you'll see, and we roll right off the screen. So the object has to stay on the screen. If this goes on for 5 seconds at 4 meters per second, how much distance are we covering? A lot. So we can just start here, and you can either click and drag and start at -4, for example, and run it. So then make it. Must have to go further back. Well, take the extreme. Go all the way back to the end. Ta-da. Okay. So now that we have that, let's go fill in what we need to write down. So what was the initial velocity? Initial velocity, we set at 4 meters per second. Final velocity, we didn't change it because there was no acceleration. So it's 4 meters per second. Direction of the velocity, since it was going to the right, as we've always described it, and it's not listed here as -4, it must be positive. Speeding up or slowing down. Was it speeding up or slowing down at all? The only way to get speeding up or slowing down is if this changes. Well, it remained the same throughout the entire process. So it must instead be 0. So there is no speeding up or slowing down. It's constant. So you could write NA or constant velocity, which is the better answer. And then the direction of the acceleration. Again, go back to the initial acceleration. It's set at 0. So there's your answer, 0. Slope of this line. Is the slope of this line positive, negative, or 0? So I won't tell you. You can fill that in. But if I were a betting man, I would fill that one in. And as we move on to the next one. Again, the hardest thing about this is it's a velocity time, not position time. Even tells you velocity versus clock reading. So it's velocity time. So now, if we start off here at 0, 0, we know our initial velocity has to be 0 because it's starting at 0, 0. But it's going to change. After 1 second, it's going to be 1 meter per second, then 2 meters per second, 3 meters, 4 meters, 5. So that means we need to have some sort of acceleration. So Go to the extremes, right? Go large or go home. So let's try that. Okay. Well, the nice thing about this is that we're in the right direction, so it's going up. It's just going up too fast. So the slope of my line is too great. So I need to back that off. And let's cut it back by half and see. Yeah, I know it's not exactly half. I'm getting closer, right? So I brought it down. It was much more extreme. Now we're bringing it down. So that means I must have to bring this down a little bit more. Hey, ta-da. So just gave you the answers to World 3-2. What was the initial velocity, final velocity? Ooh, I didn't give you that one. How can we figure that final velocity out? Well, if you come over here and mouse over it at 5 seconds when it's finally over, look at that. It tells you exactly what it might be based on the coordinates. Easy way to do this. All right. So we got that. You know the direction. Now you can tell if it's speeding up or slowing down. Because I added this in, it has to be speeding up or slowing down. What direction is it going, positive or negative? And what's the slope of the line, positive, negative, or zero? All right. Any questions? Please come and see me, but this should really help you out. And good luck. There is opportunities, I do believe, for extra credit. It's on the other assignment here, and it is labeled Universe and More Extra Credit, which should be at the end of your document. Go back to World 2 and complete those. They're very similar in the ideas. This is just dealing with some velocity and acceleration changes. So here's some opportunity to raise that grade. This will be different because this goes in right to this lab instead of being the extra credit at the end of the semester. So this really isn't extra credit for some of you. This is I must do this work. All right? Good luck.